Well, one of the nice things about verifying identities is that there are many ways of going about things. And you can try many different strategies. Some might take you a little bit longer than others. For example, we've got this identity right here. Now, one side or the other is not more complicated, right? They both look about equally complicated. And a big temptation, again, is to start by just trying to replace trigonometric expressions with identities like tangent of x as sine of x over cosine of x, and secant of x is 1 over cosine of x. And while that's tempting to say, one thing in an expression like that you might note is that, well, if there is a pre-existing relationship between the types of trigonometric functions that are already shown in that equation, by gosh, take advantage of that identity, right? Look, we've got tangent squared x plus 1 equals secant squared x. In and of itself, that doesn't seem big, but we've seen it before. Uh, if tangent squared x plus 1 is equal to the square of the secant of x, well, then the square of the tangent of x must be equal to the square of the secant of x minus 1. And that looks kind of familiar over here, right? That's the kind of thing in which we might be able to use our sum and difference factors, right? So, all right, I'm going to leave this left-hand side. I'm going to work on the right-hand side only. I've got secant of x plus 1 over tangent of x on the left equals tangent of x over the secant of x minus 1, but I want to multiply this by something to give me secant squared x minus 1, and that would be secant squared x, secant of x, we're not squared yet, secant of x plus 1. Of course, whatever I do to the denominator, I have to do to the numerator equally. So I've got secant of x plus 1 multiplied equally into the numerator denominator. So not doing anything with the left-hand side of my equation. I'm just going to leave it the way it is. I'm going to rewrite the right-hand side so that I have tangent of x times secant of x plus 1 divided by secant squared x minus 1. See, now that's sort of an interesting thing because secant squared x minus 1 is tangent squared x. So let's rewrite it one more time. We've got secant of x plus 1 divided by tangent of x in the left-hand side of this equation. On the right-hand side, we'll have tangent of x times secant of x plus 1 divided by the square of the tangent of x. And since there's a common factor of tangent of x in the numerator and denominator, I can cancel one of them out, and lo and behold, I have secant of x plus 1 over tangent of x on the left equal to, by this arrangement, secant of x plus 1 over tangent of x, which is exactly what we meant to demonstrate. So QED. We're done.